Now, because de-icers work by lowering the freezing point of water, this leads to a variety of very common misunderstandings and confusions. And I'd like to spend some time this morning trying to help us understand better what's really going on here so we can kind of get around these common confusions. So here are some examples. It's often thought that if I've got a de-icer liquid with a lower freezing point, that it's going to be a better ice melter, especially at colder temperatures. Not at all the case, necessarily. It's often thought that the lower the eutectic temperature of a de-icing liquid, the better it will work and melt ice at cold temperatures. Often the case, not always the case. We'll talk more about eutectics in just a moment. It's often thought that additives that will lower the freezing point of your brine will make it melt ice at colder temperatures. Again, not necessarily the case. So let's see if we can figure out what's going on here and how to understand all of this. So what you see right here is a freezing point curve for a standard chloride de-icer, calcium chloride. And what we're looking at here is how the freezing point of my brine changes as I add more calcium chloride. So note that as I increase the amount of calcium chloride, the freezing point of my brine drops and drops and drops until it bottoms out here at 30%. And then if I add more calcium chloride, the freezing point of my brine starts to rise again. So given that freezing point curve, what would you predict is the best concentration of calcium chloride to use for maximum ice melting power at cold temperature? You may be tempted, many people do, to say 30%. That's ideal. That's where it's going to work best because it's got the lowest freezing point. Well, is that true? All we have to do is actually measure the ice melting, and we can check that out. So I've done that for you here. This graph shows you ice melting capacities. So pounds of ice melted per pound of liquid at different concentrations of calcium chloride. This blue bar here shows you the 30% concentration with the lowest freezing point. Note, it does not give me the most ice melting capacity. The most ice melting capacity is over here at my highest concentration. And note that as I steadily dilute my calcium chloride, I get less and less ice melting capacity. This is just what we said at the very beginning, and it should be intuitively what you'd expect. The more we dilute that chemical, the more ice melting ability we lose. So how do we make sense of that with the freezing point, in this freezing point idea? Well, here's where we need to be careful. It's true that de-icers work by lowering the freezing point of water. But we need to be careful if we're talking about the freezing point of a de-icer solution or a de-icer liquid, because they're not necessarily the same. Now let me show you what I mean by that. Let's say we're going to make our little liquid de-icer. We're going to take water and dissolve salt in it. We're going to make a salt brine. So we start out with a tank of pure water, nothing in it. We know the freezing point of pure water is 32 degrees Fahrenheit. Now we start dissolving salt. We dissolve some salt in our water. That salt interferes, gets in the way of the water molecules, makes it harder to freeze. Freezing point drops. Freezing point of water drops down to 22 degrees Fahrenheit. Now, I want it colder than that. I want to get it as cold as I can. So I'm going to add some more salt. I dissolve more salt. I introduce more interference with the freezing process. Freezing point drops to 12. Add more salt. Freezing point drops down to 2. How long can I keep doing that? Can I keep dissolving more and more salt and just keep driving that freezing point down until it hits absolute 0? Well, the answer is no. Why? What stops me? What stops me is the fact that I can't dissolve salt in water forever. Water will only hold what it will hold. Sooner or later, I'm going to saturate that water with salt. So at some point, I'm going to add so much salt that the solution won't hold anymore. That excess salt will just fall to the bottom of the tank and do nothing. At that point, I have pushed the freezing point down as low as it will go. In the case of salt, it's -6 degrees Fahrenheit. That is what we call the eutectic. The eutectic temperature is the lowest freezing point it's possible to get by dissolving any chemical in water.